In this episode of the On.NET Show, we're going to be talking to Brian Peake about building games with the Unity platform. Save the date for .NET Conf 2018 on September 12th through 14th. .NET Conf is a free 3-day virtual developer event co-organized by the .NET community and Microsoft. You'll enjoy a wide selection of live sessions that feature speakers from the community and the .NET product teams. Head over to www.netconf.net to learn more and save the date. Welcome to another episode of the On.NET Show. My name is Cecil Phillip, and with me today I have my friend Brian Peake. What's going on, Brian?
Not much. How are you?
Doing pretty good. So before we start, why don't you tell us a little bit about who you are and what exactly do you do here?
I'm a Azure Cloud Developer Advocate, and I'm focused on the gaming side of the world. So video games that would use the cloud for things like compute, multiplayer, leaderboards, anything and everything that you might find in a cloud gaming backend, I want to help you with. So.
Gotcha. So that means you're familiar with things like Unity and some of these other.
Yeah, exactly. The front ends, Unity, Unreal, Monogame. I mean, there's tens, if not more, hundreds maybe at this point of game developer frameworks and engines and whatnot. So yeah, I mean, part of this is how do you plug those front ends into a cloud-based backend as well.
Cool. So let's talk about Unity a little bit.
Sure.
And what exactly we could do with it. So why don't we start with what is Unity exactly and what do we use it for?
So Unity is a game development engine. And what's neat about Unity is it has an editor and it has an engine that sits behind it. So if you're a more visual developer, it's more of a drag and drop experience. So you can actually create characters, you can create sprites and 3D assets and whatnot, drag those directly into the editor and then place them in your 3D world or even your 2D world, and then write code to move those around. And it's a very component-based model, which is a little bit different than writing kind of an event-based model like an enterprise application would be or a Windows Forms app would be. But it's cross-platform, which is one of the major selling points. So if you write your game, you can spit this out to name a platform, and Unity supports it from Windows and Xbox to there are television sets that you can export your Unity game to and install them and run them on your TV. So it's a write once, deploy everywhere with caveats, but you can get your game to a variety of platforms pretty easily.
Gotcha. So I know from building different types of applications, there's usually like a developer side and then there's a designer side.
Sure. Yep.
Is Unity more of a designer-focused application?
It straddles the border. You can do design things directly in the editor. I mean, there are some simple tools for drawing, like 3D object primitives for spheres and things like that. So if you had a very simple game, you could build it entirely inside of Unity.
Got it.
Most games aren't that simple, so you need a 3D package like Blender or 3D Studio Max, or even if you're doing 2D, you need a paint program, you need Photoshop or something to actually sit down and actually create your assets and sounds and whatnot.
Gotcha. So one of the things that was always interesting to me about Unity was I was always told, or I always heard that you could use .NET and I could write games using C# or my .NET languages for that. Is that true?
It is. It's mostly true.
Okay.
So we say that Unity runs on .NET. However, in reality, Unity runs on Mono.
Okay.
And up until just the 2017 edition of Unity, which came out, I guess maybe close to a year now, you were always stuck in .NET 3.5. So a lot of things like async and await you couldn't use inside your Unity code. You had to use their coroutines, which is just kind of a construct that exists in C# and Unity has built on top of in order to do asynchronous type things in a game. With the newer versions of Unity now, you can use APIs that are compatible with .NET 4.6. And even with the 2018 editions of Unity, you can also use code and APIs and SDKs that are .NET Standard 2.0. So with those things together, you kind of get a more modern development experience. But like I said, there are some caveats because you're running on top of Mono, you're not running on top of .NET Framework proper.
Okay. So you mentioned that it was built on Mono. So from the perspective of a developer using Visual Studio and the tooling, what does that look like? Does that mean that I have to build apps on Linux and Mac, or can I use Visual Studio, or what does that tooling sort of
It's interesting. So
like?
Inside of Unity, you would build your game. You're going to drag and drop your sprites. You're going to write the behaviors for those sprites and how they interact, collisions and scoring and all that sort of stuff. But your code editor to write those scripts is Visual Studio.
Yeah.
And you can do debugging inside of there. I mean, if you set a breakpoint and attach to Unity, you can hit that breakpoint, you can inspect variables, you can debug your scripts all the way through, just like you would in any other Visual Studio type of application.
Sure.
But when it comes to actually creating your final product, so you want your game to run on Android, you want it to run on iOS, it's not, Unity doesn't necessarily export directly to your platform. There's oftentimes an intermediate step. So in the case of iOS, for example, you want to write an iPhone or an iPad game. In Unity, when you do your export, you'll get an Xcode project. And all of that is actually, it's called IL to CPP. And this is where one of those caveats comes in. For iOS and other platforms, you get a transpiled version of your game. What it transpiles IL, the output of C# essentially, to C++ code. And that C++ code is then run through the compiler that's sitting on your Mac, in this case, in order to build the iOS version of the application.
Got it.
And so because of this, there are a few caveats of things that you can do in .NET that by the time you generate the C++ code and actually build your final project won't work. Things like reflection, because reflection's handled at runtime. But when you're transpiling that IL and spitting it out to C++, the stuff that would happen at runtime you can't account for now, because you can't account for every possible permutation of that. So things like reflection won't necessarily export correctly on a platform like iOS, because it is actually running natively at this point. It's not running on top of Mono or .NET. It's an actual native built application for iOS.
Sure. So it kind of just sounds like, depending on whatever the target is, you just have to be cognizant of what the limitations are when we're trying to publish applications to those particular platforms.
Exactly, exactly. And for most Unity games, like if you stay within the confines of a normal .NET application, there's not a lot of things that use reflection. If you're writing a Unity game, you're probably not in your script going to use reflection. But if you download an SDK, you download a .NET 4.6 SDK for something just off the internet, that would work great in a .NET 4.6 app if it uses the dynamic keyword, if it uses reflection or a couple of other things. It'll look great. It'll work great in the editor. It'll work great in a Win32 standalone build, because that runs on top of Mono. But by the time you get it to an IL to CPP platform, which that's kind of Unity's new, that's their roadmap. The concept of running it on top of Mono in the final application on Xbox, on Windows, on every platform is moving to this IL to CPP standard. So you need to make sure you test across all your platforms to make sure that you're not going to run into one of those roadblocks at the end. Okay,
sounds good. So, we've been talking a lot about .NET Standard and .NET Core, in the community in general. So what if I had a .NET Standard SDK or a library or something like that, .NET Standard 2 per se? Right? Like, is that something I could bring in and use in my Unity application? Or
so if you have a .NET Standard 2.0 or even a .NET Standard 4.6 app, you can, in Unity, you can just drag and drop the DLL into your project, inside the Unity editor. And so Unity doesn't have a concept of NuGet. It doesn't have a concept of a package manager per se. It wants the actual DLL that would come out of that NuGet package. You would throw that in the plugins directory inside of Unity. And again, if it does crazy stuff, it might work in the editor. You can press play and see it working just great, because it's sitting on top of real Mono. But once you get it to another platform through the IL to CPP engine, it may not work. One of the places where I've hit this is some of our Azure SDKs, for example. They were never intended or designed to be used on Unity. So there have been a couple places where the Newtonsoft JSON library does some reflection things with the newer versions, and those look like they work, but then when you get it to your final output, they don't. And we have some hacks and things that can get around that, but it's just something to be cognizant of.
Sure, that sounds pretty good. So I know you have some demos, right? Like, why don't we take a look at the demo really quick and see, like, kind of what this Unity development experience kind of looks like?
Sure, absolutely. So this is a demo that I wrote for Build, and we'll put a link at the bottom of the video here so you can see the full session that we did at Build for it. But this is a game called Scavenger, and the concept here is it's a virtual scavenger hunt. So every day you're given a list of 5 items to go find, and you have to take pictures of them. And through cognitive services, we determine if you've actually taken a picture of that item, and you're awarded a point or not, if you have. So as you can see, the Unity developer environment here is very graphical. This is the title screen here, and you can see on the left I have a canvas that has a background image. It has, zoom in here. There we go. It has the start button and the leaderboard button, which you can see down here. And you drag and drop these items, you create your scripts in Visual Studio, you add them as behaviors to these items, and that's how you create the game, essentially. In terms of the SDKs, as I was talking about, down here there's a plugins directory, and you can see we have the project Oxford.Vision library and Newtonsoft.json. So these are one of the ones that just happen to work in Unity and work with the IL to CPP output, and everything's happy.
Nice.
So there was no extra code that I needed to write in order to go call the Cognitive Services SDK, or the Cognitive Service that lives up in Azure. Inside of the scenes folder here, you can see this is the title screen. There's a leaderboard, which I'll show in a second here, the list of items, and then the actual camera. So let me actually start the game here, and let me have a screen mirror app here.
Oh, that's pretty cool. What app are you using to do that?
This is Visor, which through USB debugging on an Android device, you can mirror the screen to any laptop, any Windows, Mac, or I don't know if it runs on Linux, but definitely any Windows or Mac machine.
Nice.
So great for doing demos, so I don't have to have like a webcam pointed at the phone. So if I run the scavenger app here, you can see this uses a couple different pieces. So it's a Unity game that uses Azure Cognitive Services on the client, and it's also has a cloud backend. So there's some Azure functions, there's some Cosmos DB, and something called PlayFab, which is a new service that Microsoft has specifically for game development, which allows you to do things like authentication, leaderboards, achievements, and a variety of other things that would just be geared towards game developers, and very easy. It's free to use for up to many, many users, so definitely something cool to check out, and we'll have some links for that at the end as well.
Sure.
So if I click Start here, you can see it's going to show me a list of items that I would need to find for the day, slowly but surely.
So what this is doing now is, like you were talking about, there's some cloud backend to it, right?
Right.
And so now it's calling into these various services and whatnot you have there to kind of pull this data back.
Exactly.
So this is not local. This is not like syncing or anything like that.
No, this is an Azure backend. That's why it took a little bit, because it had to spin the service up, because I haven't touched it in a while.
Yeah.
So it just hit an Azure function, which pulled some data out of a Cosmos DB and is now displaying it here on the screen.
Got it.
So you can take a picture of, we'll try a keyboard here. So I get a picture of my camera, and if I take a picture of my keyboard, it will now use Cognitive Services to upload that video, or that image, and you just heard the ding, and you see there's a check mark. It actually recognized that as being a keyboard. And just to show that it's not completely fake, if I take a picture of a remote control and I take a picture of you,
Jeez.
theoretically at the top, see, not a match, please try again.
What?
So this is actually using Cognitive. You're not a remote control. So all that worked exactly how it was supposed to. So if I go back here to leaderboard, you can see, here's the people that have played.
Got it.
It was at 40 before, now it's at 41. Yeah, so all that's tied together using Unity, using .NET, using Visual Studio to edit all that code, using Azure to run the back end, and PlayFab as well.
Sure. So it sounds like as you're developing a game, like there's a lot of different pieces that are here, right?
For this game, yeah, there's definitely a lot of pieces.
Right. So it sounds like you use Unity to do a lot of that design work, right? Because as you were flipping through, I saw that you had like various tiles and I guess I know what you call them, scenes maybe, or something.
Scenes, exactly. Yep.
Right. So you had these different scenes, right? And so now, again, through your Unity scripts, like you'll edit whatever's happening or motion or anything like that that's coming up in those screens.
I'll actually jump over to Visual Studio here, and I can pull up one of the scripts to show you. Let's look quickly at, what's a good one to look at? We'll look at the camera behavior. So this is the screen that actually takes the picture.
Okay.
So everything in Unity, almost everything from Unity inherits from what's called a mono behavior. A mono behavior always gets you kind of a start, which is your initialization, and an update, which is every frame, what do you want to do?
Got it.
And then inside of here, you grab some instances of various objects, like the camera button, the spot where you want to drop the image in, the audio for the ding that says you're right, or the buzzer that says you're wrong. And essentially, inside of here, once you've grabbed those objects, this is very much .NET. In order for me to grab the clip for sending it to Cognitive Services, I grab the texture from the camera, I encode it to a ping, I put that in a memory stream, create a Vision Service client object, which is the standard Project Oxford client SDK. Have my keys, pass in that memory stream, which contains the image, and you can see I'm using await. So this is using, again, .NET 4.6 async await. In old versions of Unity, you would have to do coroutines and whatnot, and these things wouldn't be compatible. This was simply me taking that SDK, dragging and dropping it into Unity, and it works. and then pulling back the result of the tags and determining if that tag matched what I expected it to be. So
Got it.
we have a predetermined list of tags for each object. So like a keyboard, you don't always get back keyboard from cognitive services based on what keyboard you've taken a picture of. Sometimes it comes back as computer.
Yeah.
We'll take both of those things. I mean, it's close enough if a computer, if cognitive services recognizes that as a computer, we know that you've actually taken a picture of a keyboard.
Gotcha. So what I wanted to know was, so you're showing me Visual Studio right now. How do I take the output of Visual Studio, right? Like how do I take these assets that are here and put them into Unity?
It's automatic. So inside
really?
of
Okay.
Unity here, I have a scripts directory right here. Can zoom in on that.
Yeah, zoom in a little bit.
So I have a scripts directory. And so everything inside of Unity lives inside of this assets folder. So I have some animations, I have fonts and pictures and icons and whatnot, and scripts is where all of your C# code lives.
Yeah.
So for each one of these, you right-click, you right-click and do create C# script.
Could you move the magnifier out of the way?
Get out of the way.
Yeah, you could minify it.
Oh boy, let's pop everything up at the same time. There we go.
There you go.
So yeah, so you would right-click inside of here, say create C# script.
Got it.
And that's going to drop it inside of Unity. And then to edit, you just double-click on the script, and it's going to open it up inside of Visual Studio automatically.
So even though it says C# script, right? Like we're not talking about CSX files.
No.
Right.
It's full-on, honest-to-goodness, real C#.
Right. So it's actually just a DLL, right? Like a compiled DLL. Right.
At the end of the day, yeah, when you spit all of this out, you will get what's called there's a Unity assembly.dll or something like that, which is actually what contains all of your mono behaviors, all of the code that you've written inside of Unity.
Got it.
And that's actually what's being executed on the client side.
Cool. Let's talk about some of the backend services that you use to kind of make this happen, right?
Sure.
So as you're building a game, I'm assuming like it's just not my device by itself.
Right.
Right. Like there's a database and there's web services and there's assets and there's different things that you're pulling in to kind of make this thing work, right?
Sure.
So like what are some of the features that you needed or you pulled into your app to kind of make it do what it does today?
Yeah, so for what I wanted to do is I wanted it to be a very simple game of take a picture, determine if it's the right thing, award a point. Very simple, but I couldn't do all that locally on the device.
Right.
Because obviously you want a leaderboard, you want to play against multiple people. Every day I want to have a new list of items, so I need to pull that list of items from somewhere in the world. All of the assets and artwork and sound work was stuff that either was created by a friend of mine who's an artist, Joey. He created the logos and all that, and I have no artistic ability, so I always need help there. Sound effects came from a free sound package that I found. But in terms of the services, it uses Azure Functions, which I'll show the code here inside of the server project.
I'm guessing you're using your Azure function as like an HTTP endpoint, I'm guessing?
Exactly, that's all it is, an HTTP endpoint, and I think there are 4 of them. Get daily items, which is exactly what it sounds like. What are my 5 items that I need to find today?
Got it.
Item found, which is when you found the item, we call that to say award the point, essentially.
Sure.
There is a PlayFab piece here, which does the login and leaderboard and whatnot, and just a couple of admin things. So there's really only just a couple of functions that can drive this whole thing.
Nice.
Get daily items, for example, just goes in and we have a Cosmos DB backend. Uses the HTTP trigger and the document DB binding in order to tie you to that database, and using some simple link. So what's kind of neat here is this is all C# from end to end, from Unity all the way through to your backend and back to Unity again. It's all C#. We could have written this in Node. You could have used something else on the backend. Sure. But if you're a Unity developer, you already know C#, and Azure Functions to be written in C#. So why would you use something else necessarily?
Gotcha. Sure. That makes sense.
So using some simple link here, I can pull back a list of those 5 items and then put them into an array and send them back down to the client for display.
Gotcha.
The client is essentially like a dumb terminal. It's just displaying, it's calling the service, getting the list, calling the service to determine if the object was found, calling the service to add the point. It's just displaying what the server tells you. And you need that because you want to have a secure game. There are cheaters. There are cheaters everywhere. Someone's always going to try to hack your game. Right. So making sure that you have an authoritative game server in this case. The game server is really what determines everything. You're just displaying what the game server is telling you. That's how most multiplayer games work.
I think another benefit that you get from that as well is that like you're taking that onboard processing and you're moving it somewhere else.
Yeah, exactly.
Right. So when you think about things like preserving the battery and not killing your user's phone while you're
Sure,
using
sure.
it. Or like I'm sure those things come up a lot in terms of like again deferring that compute to the cloud or some
They
backend
do, they
service.
do. And there are games that are starting to use the cloud for things like physics,
Right.
which can be very CPU intensive and complicated. And if you're on a lower end machine, you don't necessarily want to burden the PC with that or the console with that. You can run those simulations on the server and just send down to the client. Well, this is what the world looks like now.
Yeah.
And display it that way. You didn't have to do the calculation. I'm just telling you this is what it looks like now.
Got it. So let's talk about really quickly, like, so what are some of the targets we have from Unity? So you showed us a mobile game a little while ago.
Yep.
Right, but can I think you also mentioned television, right?
Yep.
But so what are the other places I could send these? Can I create like Xbox and PlayStation games?
Yeah, absolutely. You can do, so Mac, Linux, and Windows are kind of they're called the standalone build. Those are the kind of the original. You can spit out to iOS, Android, Xbox, PlayStation, Nintendo Switch, Android. I don't know if I said that already. I probably did.
You really like Android phones.
I really do like Android phones. That's just me. They're like there's a Samsung has a .NET platform that runs on their televisions, and I forget the name.
Tizen, is that what?
Tizen.
Right.
I'm not sure. Unity used to have a Tizen exporter. I haven't tried it lately to see if that's still up to date. You can even spit it out to WebGL. There's there's an output that will build a web page in JavaScript, and you can run your game in WebGL in a browser. If it's not too complicated. Sometimes it gets a little tricky, but.
So tell me if this is a bad analogy.
Okay.
And if it's a bad analogy, tell me and we could cut it from the video.
We'll just cut it right out. That's fine.
Is Unity kind of like the Xamarin for mobile, for writing games in general? In terms of like I could write some code and I could have multiple targets.
Yeah.
And I could deploy them to these multiple targets.
Absolutely.
But I could have a shared like code base.
You can have a shared code base, exactly. And you can, just like with Xamarin, you can if-def out parts of your code where, the process for doing something on Android is completely different for the process for doing something on iOS. And Unity tries to create common interfaces for that in many cases, but there are still some things that, one of the things is like the camera interface. Unity doesn't necessarily have a completely 100% generic camera.
Yeah.
So you can, if you want to write Java code in order to, on Android, to go talk to the camera, you can do that. And that'll only be compiled for the Android version of your game.
Got it.
And if you want to do the same for iOS in Swift or in Objective-C, you could do that,
right?
And create these little libraries and things. But yeah, no, calling it the Xamarin of game development is pretty accurate. I will say that Monogame, which we might talk about in a future episode, literally is the Xamarin of game development because it runs on top of Xamarin on the other platforms.
Oh, really?
In many cases, yeah.
Oh, nice. We're going to have to talk about that one soon.
Absolutely.
So this all sounds really good. Why don't you tell us really quickly, what are some of the places that I could go to get started with Unity?
Sure. A couple of links open here. I would say, for Unity itself, there's unity3d.com if you want to go and download the engine. They have a ton of documentation and samples and things under Learn. If you want to run through those, they have some great samples and starter kits. So I want to write an RPG game.
Yep.
They've got a starter kit for that, or I want to do a platformer. They kind of show you how to do that. In terms of some of the Azure stuff that I've been working on, we have our site called The Sandbox, which is on docs.microsoft.com. Again, we'll put a short link down in the video. But these are prepared SDKs that we know are working with Unity. None of the caveats that we talked about with having to worry about IL to CPP. These have been tested and are known working. So you can go here and click on our Unity tab, and we have a handful of SDKs and 3 or 4 samples as well on how to use stuff like easy tables or Facebook authentication from inside the Unity editor.
Cool. Well, awesome, man. Thank you so much for coming on, Brian. That was pretty good.
Thanks for having me. Get started with game development. It's fun. It's not as fun as playing games, but it's still pretty fun.
Okay, so let me ask you this then. Like, what is your favorite Unity game that you've played?
Actually, I have an answer for this. My favorite Unity game is Ori on the Xbox. Ori and the Blind Forest. That is a Unity game that has taken Unity to a level for 2D that I don't think I've seen anywhere else. It's a beautiful game. Cuphead would be another one. Cuphead's a Unity game as well.
Is that a family-friendly game? I don't think it's a family-friendly game, though.
No, it is.
Is it?
Yeah.
Cuphead?
Cuphead, yeah. You're just fighting random, enormous bosses. Like, it's old school, like Mega Man style bosses that just beat on you. And it's really hard, but it's a fun game.
All right, we're going to have to check it out, man.
Yep.
But hey, thank you again, Brian. So,
thank you.
Really appreciate it. And here's another episode of the On.NET Show. We just learned all about building mobile games and all different types of games with Unity.
You got it.